All right. Hello, Algebra 1. Right before our state test, we were talking about quadratics, specifically solving quadratics. That was the unit we did right before. We have not taken the assessment over this, so in this upcoming week, we will take the assessment over solving quadratics. So in order for us today, we will then review those couple different methods. So we had some different methods of solving quadratics. We had three methods that we talked about, and then we also had systems of quadratics that we'll talk about. So the first thing we talked about was factoring, solving via factoring. So once again, factoring, whenever we're factoring a quadratic, we always have to think through that X in box method. That was our method for factoring. So when we factored, we took the first number and the last number, we multiplied those together, and we put that in the numerator of our quadratic. So for example, x squared times 21 would be 21x squared. We then took our middle number, and that went in the bottom of our little x, and that was 10x. We had to think of two numbers that multiplied to get the top and add to get the bottom. So two numbers that multiply to get 21x squared and add to get 10x. Well, I know 21 is multiplied by 3 and 7, which add to get 10. So 3x and 7x. So once I got those pieces, I'm going to start filling in my box. I know my first and my last box are always going to be my first and my last, my x squared and my 21. My two other boxes are going to be filled in with what I came up with, my 3x and my 7x. Then from here, we just had to fill out the outside. So what two numbers multiply together to create x squared? Well, it's x and x. What two things multiply to create 7x? Well, it's x times 7. And x times what number creates 3x? X times 3. 3 times 7 creates 21. So I know my two factors are x plus 3 and x plus 7. So once we factored, we knew we could use this to help us solve for the quadratic. Because whenever we're solving for quadratics, we're always solving for when it's equal to 0. So by the zero product property, in order to have two things that multiply together and have them equal 0, one of those two things at least has to be equal to 0. So either x plus 3 has to be equal to 0, or x plus 7 has to equal 0. So we know our two solutions of when this will be equal to 0 is when x plus 3 equals 0 and x plus 7 equals 0. And that's just two equations I need to easily solve. So minus 3, and I get x equals negative 3. It's always going to be that inverse of what showed up in my factor. Minus 7, and I get x equals negative 7. That inverse once again. So x minus 3 and x minus 7 works. I could plug this into Desmos. I could graph this, and I would see I have a y-intercept at negative 3, 0 and negative 7, 0. And that would be my quadratic. We can do this other one as well. We have 4x squared plus 19x plus 5 equals, once again, we're always solving for when they equal 0. We're solving for the solutions, the zeros, the roots, all those different words. So first thing I have to do is I create my box and my diamond. Once again, in the numerator of my box, once again, I know I multiply that first and the last. So negative 4x squared times 5 is going to give me negative 20x squared in the top. And then 19x is going to be in my bottom part. So two numbers that multiply to give me negative 20, add to give me 19. Well, 19 is an odd number to add to. And I know some numbers that multiply to give me negative 20 are like 5 and 4, 2 and 10, but none of these are going to give me 19 in any way through addition. But if I do negative 1x and 20x, those multiply together to give me negative 20 squared and add together to give me 19x. So I'll have in my numerator negative 4x squared, in my denominator 5, or in the bottom part of my box 5. Then I'll have negative 1x and 20x. Now I just need to start filling in the outside. Two numbers that multiply to give me negative 4x squared are going to be, I have obviously x and x to give me the x squared. Now the negative 4, I see that this row right here has factor is divisible by 4. This row is not divisible by 4. So I'm going to put my 4 over here. But if I do look at this row both has negative numbers. So I'm going to put a negative with that x. So negative x times 4x gives me negative 4x squared. 4x times what number gives me 20x? Well, 4x times 5. And negative x times what number gives me negative 1x? Well, it's just going to be 1. And 1 times 5 gives me 5. So I would have 4x plus 1 as one factor, and negative x plus 5 as my other factor. Those are both equal to 0, so I can set them each equal to 0 and solve. So 4x plus 1 equals 0. I would have to inverse my 1, inverse the 1 to get negative 1. And so I have 4x equals negative 1, and then inverse my 4 to get x equaling negative 1/4 or negative 0.25 is one factor. The other one, I have negative x plus 5 equals 0. If I subtract 5, I get negative x equals negative 5. If I divide by negative 1, I can get rid of that negative, which gives me x equaling positive 5. So my two solutions would be 5, 0, and negative 1/4, 0. So factoring was one easy method we could use. One thing we had to remember, factoring did not work for all quadratics. Sometimes we get some ugly numbers, like some irrational numbers that we could not factor. So when we could not factor, we had to use something that used square roots because we're getting those irrational solutions. One such method was solving using square roots. When we only had one single x in the one single x in the problem, one single x in that trinomial or that quadratic, we could solve by using square roots. For example, 4x squared minus 13 equals 15. We can solve this just by getting x by itself using those inverse operations as if I'm solving an equation. If I add 13 to get x by itself, I have 4x squared equals 28. I can then divide by 4. Once again, I'm trying to get x by itself and use those inverse operations. That gives me x squared equals 28 divided by 4 is 7. Okay, so once I get x squared, in order to get rid of that square, I know the inverse operation of a square is a square root. So I take the square root, which is going to cancel out my square, which is just going to leave me with x. But if I take the square root of one side, I have to take the square root of the other side. So I have to take the square root of 7. Now, if you plug square root of 7 in your calculator, you're going to get some ugly number like 2 point something, 2.5 something, something, something. But we also know that it's not just 2.5 something, something that multiplies together to give me 7, but it's also negative 2.5 something times negative 2.5 something that multiplies together to give me 7. Because that positive, there's always a positive and negative solution of my square root. I'm going to keep it as just radical 7 in order to keep it as the simplest version. But my two solutions would be positive square root of 7 and negative square root of 7 would be the two spots of when this quadratic hits 0. Or another example is x minus 1 quantity squared equals 25. So I need to get that x by itself once again. So the first thing I see that's on the outside of my function is the square. So I'm going to inverse it by taking the square root. If I take the square root of one side below, once again, I have to take the square root of the other side. So that square and square root are going to cancel out. I'm just going to be left with what's inside, which is the x minus 1. And that's going to equal the square root of 25. Well, the square root of 25 I know is positive 5. But once again, every square root is always going to have two solutions, the positive version and the negative solution. Because I know that negative 5 times negative 5 also equals positive 25. Well, positive 5 and positive 5 equals 25. So there's two solutions to that square root. So now that I have two possibilities, I need to split this into two questions. X minus 1 equals positive 5, and x minus 1 equals negative 5. And I need to solve each of these. So I'm going to add 1 to get x equals 6. And I'm going to add 1 to get x equals negative 5 plus 1 is negative 4. So those are going to be my two solutions. At 6, my quadratic is going to hit 0, or x minus 1 squared is going to equal 25. And at negative 4, x minus 1 squared is also going to equal 25. Those are my two solutions to this quadratic. Once again, we can only use solving by square roots when there's only one x. So once again, factoring can't work with everything. Solving by square roots can't work with everything. We did have a third method that could work all the time, though. This was our wonderful, happy, beautiful quadratic formula, which we had a lovely song that went opposite of b plus or minus square root b squared minus 4ac all over 2a. And we could use this quadratic formula to help us solve for these quadratics, to help us solve for these solutions, these zeros. All we had to do, though, in order to find the quadratic formula was write down our A, B, and C, A, B, and C, and then we would be able to solve. But in order to do this, we always had to make sure our quadratic was equal to 0 first. We could not solve it if it was not already equal to 0. So my A is always the number from my x squared, which in this case is 2. My B is the number from the x, which is 8. And then my C is my last constant value, which is negative 10. Once I have these numbers, I just need to plug them into my quadratic formula. So opposite of b would be negative 8 plus or minus the square root of b squared, which would be 8 squared, minus 4 times a of 2 times c of negative 10 all over 2a, 2 times 2. And from here, I just need to simplify this. Honestly, if you wanted to, you could plug this whole thing into the calculator. Once all as plus and then once all as minus instead of having that plus or minus there. and that will give you the two different solutions. But we know the first thing that's probably easiest to do is get rid of this part, the part that's under the square root. So I'm going to do negative 8 plus or minus the square root of 8 squared is 64 minus negative 10 times 2 times, or sorry, negative 4 times 2 times 10, which if I multiply all that together, that's going to give me positive 80 all over 2 times 2, which is 4. So I have negative 8 plus or minus 64 plus 80 all over 4. So this is going to give me negative 8 plus or minus, well, 64 plus 80 is going to be square root of 144 all over 4 once again. I'm going to extend down a little bit. From here, I know the square root of 144 is just 12. I can plug that into the calculator. So negative 8 plus 12 over 4. Now it's plus or minus 12. So here, now I'm going to have to split it into two different problems in order to get those solutions. I'm going to have negative 8 plus 12 over 4 and negative 8 minus 12 over 4. Negative 8 plus 12 is just going to give me 4 over 4, which is going to give me 1 as one solution. Negative 8 minus 12 is going to give me negative 20 over 4, which turns into negative 5. So my two solutions are 1 and negative 5, and I am done with this quadratic. So once again, all we had to do is find the a, b, and c once our quadratic was equal to 0, plug it into that quadratic formula, and then just work through the algebra, and you are good to go. We could do the same idea with this second question. Once again, I need to write down my a, my b, and my c. My a is 1, my b is negative 4, and my c is 8. Plugging it into my formula, I get opposite of b, which is going to be positive 4, plus or minus square root b squared minus 4ac all over 2a. And then I can start working through this. So once again, I always like to work with the center part first. So negative 4 squared is 16. So I have the square root. I have 4 plus or minus the square root of 16. Negative 4 times 1 times 8 is going to be negative 32. So 16 minus 32 is going to give me negative 16. But here's where we had an issue in the past. In the past, we could not solve negative 16. That did not give us a real solution. It did not give us a real number. So what we had to do was we had to simplify the square root using complex solutions. So sometimes our quadratic formula gave us complex solutions, those imaginary numbers. So what I had to do is I'm going to have to take the square root of 16, negative 16, and I'm going to have to break this down. I know it's a negative, so I know it's going to give me negative 1 and 16, which negative 1 is just going to break down into our imaginary number I and I, which I can circle cross one out like I usually do. 16 is going to break down into 4 and 4, which I can circle and cross one out. So I'm going to have 4i and nothing in the radical because everything broke down or crossed out. So 4i is going to be the square root of negative 16. So once again, we get those complex solutions, those imaginary numbers. So this is going to be 4 plus or minus 4i over 2. Now, something we talked about before, just like I can't add an irrational number to a rational number, I can't necessarily add those together. What I can do is I also can't add complex numbers to real numbers. So 4 plus or minus negative 4i, I have no idea what that's going to be. But what I can do is I see all three of these numbers are divisible by 2. 4, 4, and 2 are all divisible by 2. So I can divide them all by 2. So 4 divided by 2 gives me 2. 4i divided by 2 is 2i. And then 2 divided by 2 is 1. So this is going to simplify into 2 plus or minus 2i all over 1, but dividing by 1 isn't going to change my problem. So 2 plus or minus 2i is the most simplified version that we can get for this solution because I do not know what a complex solution plus an irrational or a real number is going to give me. So I'm just going to have to leave it with 2 plus or minus 2i. So once again, quadratic formula works all the time, but sometimes it gives us those complex solutions for those problems that we could not solve using the other two methods. Last thing we talked about in this unit was our quadratic system. Now, quadratic systems wasn't necessarily a different method of solving, but it was looking for the solutions when we had these quadratics and another equation. So we're seeing when does the equation y equals x squared minus 5x plus 7 equal the same thing as y equals 2x plus 1. So when are these two equations equal to each other? So x squared plus 7, when is this possibly going to be equal to 2x plus 1. All we had to do was set them equal to each other, and then from here we have to solve. In order to solve this, though, I know I have to get one side equal to 0. So I cannot have this information over here. I need to move it. So I'm going to inverse it by subtracting 2x and move it over to my 2x over here, which is going to give me x squared minus 7x plus 7 equals 1. Then I can subtract 1, and we get x squared minus 7x plus 6 equals 0. So now that I have it all as one single quadratic, I can solve for the solutions of this quadratic, and that's going to give me the x values of the two locations, the two answers of my system of quadratic. So what I'm going to do is I can choose any of my methods that I talked about before. Quadratic formula or factoring should work on this. I cannot use using square roots because I have two x's involved, so I won't be able to solve for a single x. I'm going to use factoring. I think that's a little bit faster, so I'm going to create my box in my diamond method. In the top, I'm going to have x or 6x squared. In the bottom, I'm going to have negative 7x. Two numbers that multiply to give me 6x, add to give me negative 7x, are going to be negative 1x and negative 6x. Together, they multiply to give me positive 6, add to give me negative 7x. And so I'm going to have x squared and positive 6, negative 1x, negative 6x, and we are just going to solve this by factoring. So x times x gives me x squared, x times negative 6 is negative 6x, and x times negative 1 is negative 1x. So I have x minus 6, x minus 1 equals 0. Those are my two factors. I know it's just the inverses of these are always going to be my solution. So I'm going to get x equals positive 6 if I were to solve that, and x equals positive 1 as my other values. Now, these are the two x coordinates, but I'm looking for the two locations, the x and y values. So I need to figure out what are the y values of each of these points. So in order to find the y values, I just need to plug these x's back into either of these two functions to figure out the y value. Looking at these two functions, though, this one is so much easier than the first one. So I'm going to plug 6 and 1 into this function. I'm going to see what are those two outputs. So I have y equals 2x plus 1. Let's plug in 6. So y equals 2 times 6. If I plug in 6 for x plus 1, what does y equal? Well, 2 times 6 is 12, plus 1 is 13. So this coordinate, my first solution, is going to be 6 as the x coordinate, 13 as the y coordinate. I'm going to do the exact same thing again. Y equals, but I'm using 1 this time. 2 times 1 plus 1. 2 times 1 is 1, or sorry, 2 times 1 is 2, plus 1 is 3. So 3 is my y coordinate. So I'm going to have a 1 as my x and 3 as my y. These are the two solutions to my quadratics, 6, 13 and 1, 3. If I were to graph both of these two together, the system of quadratic and this x, I would be able to graph both of them at the same time, and I would see that they're going to pass together at 6, 13 and 1, 3 are the two solutions. So those were the things that we had talked about in this most previous unit that we've just gone over. Let me know if you have any questions. We're going to have some time to practice over this, and then we will have our assessment soon. Let me know if you have any questions.